Okay, guys, welcome back. So the time has come. This is actually our last lesson for the summer term of Adult Basic Education Math. And I'm really sad to see it come to a close, and I'm going to miss talking with all you guys. I think we've gotten a great deal of things accomplished and completed over the last however many weeks it's been. I think we're at like the 2 month mark or something. I don't remember exactly how many weeks, but it's been such a fun ride, and making these lessons for you guys has been so cool, and I hope that it's been really useful for you in terms of what you're learning about mathematics. And if I might see you in the fall for the fall term. I'm not really sure about that right now, but if I don't, I wish you guys the absolute best of luck with everything you do in your future. I always believe that the things that you have to do in life, you just got to grab them by the horns, and you got to do it. You got to make it happen for yourself, because the older you get, the less people there are out there that are trying to make things happen for you. So, with that being said, let's go ahead and we will conquer level D topic 5, and I think after this there's only one more level after this, which is level A, which we're not going to get to that, of course. I'm actually going to check really quick and see how many other lessons there are in level D. Okay, so there's two more topics in level D, 2 more lessons, and then when you get to level A, there's 4, 5, 6. There's 6 altogether. So really, there's only 8 topics left inside of this course in everything that we've done so far. So with that being said, let's go ahead and cover our last bit of material here. This topic is called the equation of a line. There's quite a bit of build up here before we actually start graphing lines. So let's go ahead and do it. So we graph lines on this concept, this thing called a coordinate plane. It's actually called a Cartesian coordinate system, but that's super. We don't need to go into all that. It's a coordinate plane, and what it is like if you think about a number line, right? So we've drawn number lines before, okay? And let's say this is a number line, and you have 0 in the middle, right? Here's 0. You go to this direction, it's 1, 2, 3. If you go the other direction, it's -1, -2, -3, right? So a coordinate plane. Okay, before I even talk about the coordinate plane, if I asked you to plot the number 2 on a number line, you would just go to number 2 and plop down a little dot right there on a 2, right? So the same type of thing can be done when you're talking about something that's happening in 2 dimensions or 2 variables. A coordinate plane is really just you add another axis to this, right? You have an up and down axis, okay? And this has measurements that go this direction. So this is still 0 in the middle, but you can go up 1, 2, 3 and down -1, -2, -3. That's a super crude drawing, by the way, so sorry. We're going to look at a real coordinate plane in just a moment. But this is basically the gist of how a coordinate plane is constructed. And the reason why we have these is because in algebra, one of the fundamental things that we cover as just a topic of algebra is the comparison between 2 different variables, and what is the relationship that exists there, or is there not a relationship there? Usually there is, and that's why we graph them. If I gave you a table, right, with a bunch of numbers in it, that after taking some time to really look at everything, and you might need to make some notes and draw some stuff down and do some calculations, and after looking at that data, you might be able to draw some conclusions about what's happening with the 2 variables. And typically when we talk about the relationship between the variables, we're asking, as one variable changes, it gets bigger or smaller, does the other variable get bigger or smaller, or does it stay the same? Or as the first variable stays the same, does the other variable get bigger or larger? Those are the types of relationships that we are talking about. And if you want like something real life that you can kind of like really ground this concept into, think about the tank of gas that's in your car, right? Like it has a certain capacity. That's not important. However many gallons it takes, right? Let's say you can fill up 20 gallons and that's a full tank, right? If you put 20 gallons of gas in your car, you're going to be able to go a certain number of miles, right? I mean, that just makes sense. Whatever the maximum, mileage your car can get, you might get that with the full tank of gas. Well, if you only filled up 3/4 of the way, you're going to be able to travel fewer miles. You're not going to be able to go as far because you don't have as much gas. So the relationship here is that the more gas you put, the more miles you'll be able to travel, okay? And the less gas you put, the fewer miles you'll be able to travel. That's the relationship that's happening here. And that is what we're talking about. That's at the heart and core and soul of algebra. That is what we do, and that's why we study algebra. We study algebra because it helps us examine relationships between, we're talking about things like x and y here, but we try to make it be modeled in something in real life as often as we can, because algebraic thinking teaches you how to examine things that are happening in the world around you. That's why it's so important. I get this question all the time from my students, because they haven't quite gotten the concept yet about why it is that we study math. Why do we even do any of these things in mathematics that have all these special terminology and all these rules you have to remember? Why do we do that? And this brings me back to when we had our orientation night, because I sort of touched on this a little, and some of you weren't there for that, and that's fine. But on orientation night, we sort of talked about why it is that, I appreciate the study of mathematics and why you should also appreciate that study of math. And it's because, math gives you a framework. It teaches you how to think logically and how to approach things in your real world around you from a mathematical, logical perspective and standpoint. I'm not saying that you're going to take the SlopeIntercept Form and apply that to like something that's happening in your real life. You might. I mean, it depends on what you're looking at. But, I'm not saying that you need to memorize every single formula we go over, because you're going to go out into the world and have to figure out, the area of a circle all the time and whatever. And it's especially difficult in this day and age because we have, a calculator in our pockets at all times. We have our cell phone, and our cell phone, you can go to Google and search for, the area of something and it'll calculate it for you, right? But I still argue with that perspective, because if you don't even know generally what it is you're trying to accomplish logically, you won't know that you need to find the area. You know what I'm saying? Like if you're trying to buy a rug for a room, without first measuring the room and seeing how much floor space there is, and then figuring out that area, you're not even going to know, oh, it's the area. I might need to figure out, how much area of the rug I need to be able to cover here. And rugs are sold in dimensions of length and width, not by area. So when you go to a store, you see rugs that are like 5x7 and 10x14 and stuff, and those are the length and width. So if you know that you only have a certain area that you can fill, you're going to need to be able to figure out what's the area of a rectangle so I can buy the correct rug that has the right amount of area of carpeting on it, okay? That's just, I went off on a tangent a little bit, but I want to, if I leave you with anything from this whole, this whole course, it's that, and that is the study of mathematics is so important to just how we logically think about and approach things in our world, in real life, and that's why we study things like this. So let's take a look at what a coordinate plane looks like, okay? On a coordinate plane, so this is what one looks like. You have a horizontal axis, right? This is one variable's axis. It might be x, it might be a, it might be time, it might be, whatever your problem has in it. And then you have a vertical axis, which is going to be, in most cases, the y-axis, because you normally use x and y to talk about things in algebra. And what this allows you to do is it allows you to compare the relationship between these two variables because they are plotted in such a way that you can look at them side by side. So there's a couple things we have to know about what the parts of the coordinate plane are. The first is this middle point right here, okay, and I'm going to draw an arrow to this. This is called the origin. Okay, I believe this is defined. Yeah, I defined it down below. Okay, that is the origin. We're going to talk about what that means in a second. And then you have the x-axis. And the axis literally just means the line that goes across this way. That's what the axis is. You also have the y-axis. That is the vertical axis of this graph. I think there's one more thing. Oh, coordinates. Okay, so you also have coordinates. We'll talk about what that means in a second. Let me unzoom this a little so you can see the definitions as well. So x-axis is your horizontal, the y-axis is your vertical one. The origin is the absolute center of the coordinate plane. Okay, if I just told you to compare x and y and didn't give you a starting point, like that would just be complete chaos. Like it would be so impossible. You always have to have a starting point, and that starting point is always the origin. Okay, it's where the two axes, the x-axis and y-axis, intersect. The coordinates of this point are 0, 0, okay, because you're not going left or right, and you're not going up and down. Okay. Finally, we have this concept of a coordinate, and if you think about a coordinate, right, like you have probably seen maybe in like early geography and stuff, like maps have coordinates, right? So let's say you have a map. Here's a map right here, and there's some landmass on your map, and we're going to call this I don't know what country this is. We're just going to say this is an island, okay? And then this is all the ocean surrounding the island, right? Okay, so here's your ocean. Okay, and a map usually has like all these horizontal and vertical lines like this that go across, and they have like 1, 2, 3, 4, 5 this way, and 1, 2, 3, 4, 5 this way. And so what this is like a coordinate system, because if I wanted to tell you where a specific thing was on the island, it might be difficult to like describe it to you like by landmarks, because that would be very hard to do. It's the coconut tree that is around the left corner of the mountain next to the sea, and like that could literally be anywhere on this island. But if I told you it's the coconut tree that's exactly at 4-2, that might be like right here on this island. And I've given you an exact coordinate of how to get there. I used one of the upper numbers and one of the side numbers, latitude and longitude, to tell you where this was, okay? With that example set aside, let's apply that to what a coordinate plane system typically does. Typically on a coordinate plane, you're going to have coordinate points. And a coordinate point gives you one number that's on the x-axis and another number that's on the y-axis, and it looks like this, x comma y. And what this tells you to do is first it tells you where do you go on the x-axis left and right. Then it tells you from that point where do you go on the y-axis up and down. Okay? So let's use a different color, and let's say I give you a point that said -2, 4. How do you plot this point? Where is this on this quote-unquote map of this coordinate plane? Well, first you're going to follow the x-axis and go to the left 2. That's -2 on the x-axis. The dot does not go there because you also have to do the y-coordinate. And this says to go +4 on the y-axis. So -2 and then +4 up 2 gives me a point right here. This is -2, 4. That is how you plot a point on the coordinate plane. I think the next thing, yeah, this is also about the points. So I saw this graphic and thought it was really good. So we have the origin obviously in the middle here. You have this red point, which is -3, +1. That means we went 1, 2, 3, and then up 1. And it actually shows you like how you would trace over to where that is in case you didn't have the lines here. You should always have the lines though. You have this other point which is in green, which is 2 comma 3. That means the x value is 2 and the y value is 3. So I'm going to go 1 2 and then 1 2 3, and that's my point. Okay. You also have this blue one, and they threw something else at you in here, and it's fine. They put decimals, right? So it's 1.5 or 1.5, and 2.5, which is 2.5. They're also both negative. So you're going to go to the negative 1.5, so 1.5. And then you're going to go down, because it's negative 2.5, 1, 2.5. And that's the point that you're at down here. So that's just an example of how some of these points got graphed. There's this concept of there being 1, 2, 3, 4 different quadrants of the coordinate plane. We don't really cover the quadrants in this content, in this curriculum. I think you touch on it in level A. So we're going to skip that for now. We're not going to overload you too much on what the coordinate plane quadrants are. But that is the basic parts, and the axes, the x and y axes, the origin, which is the dead center middle, and then how you would plot various points on the coordinate plane. If you need additional help with how this is all constructed, here's 2 YouTube videos for you that you can pull up. If you go to Google Classroom and you open this document on your computer screen, you can actually just click on these. They're links. And they'll take you right to YouTube videos. They're pretty short. They're like a couple minutes long, and they just do a real brief rundown, kind of how we just did, about what the different parts of the coordinate plane are. It's important that you have a solid understanding of how the coordinate plane comes together, so that when you move on to more like rigorous graphing type of scenarios, this is a piece of cake, so you can handle the graphing really easily. So we're going to talk about looking at linear equations next and making what's called a table of values. So this would be a great time to take a breather, take a pause, use the restroom, grab a snack or a drink, or both. Whatever you need, this would be a good time to pause, and then when you come back, we'll start the next major part of the notes, which is creating table of values. Okay, so let's move on to the next section of this topic, which is going to be about creating a table of values. So we have talked about solving equations before. That's when you have an equal sign, and that means the equal sign means that everything on the left side is equal to everything on the right side. And so when you have an equation, when we're talking about graphing, typically you have 2 variables, and you're not just solving for one variable. Okay, you're going to need to figure out what are some possible solutions that would satisfy both variables so that the equals sign is still true. There's a really easy way to do this, and that's by making a table of values. So I also want to talk about the difference between an input and an output. And for the purposes of these problems, the ones we're covering in this section here, the input is always going to be the x, and the output is going to be the y. And what do I mean by input versus output? So what this means is that in comparison to y, we are always figuring out, when we plug certain things in for x, what do we get as an output for y? Okay, we're not going to be doing it in reverse because that's going to take up way too much time. We're going to focus on the way that it's written already, which is that the y, whatever the value of y is always going to be found by plugging in 4 times x and adding 2 to it. Or in this equation, the value of y is always going to be the x value you're looking at minus 4, and so on and so forth. And that's how input and output works. And so typically when you have to make a table of values, what you want to do is you want to start near the origin. So if we are talking about that coordinate plane of x and y, the origin is this spot in the middle. Well, what's the x value here at the middle? Where is this? It's at 0. If I were to go to the right one, that would be 1. Just like a number line, this would be 2. This would be -1. This would be -2. Okay? Usually what you're looking for is you would be looking for something like, what happens to y when x is 0? What happens to y when x is 1? What happens to y when x is 2? This is a good place to start for our purposes for what we are covering in this particular topic. So let's stick with that. If I were to plug in 0 for x, that would be, and I'm going to do the work. I'm going to do all this work right here, okay? Y equals 4 times 0 plus 2. So 4 times 0 is 0, and 0 plus 2 is 2. So when x is 0, the y value is 2, okay? That is it. It's not going to be anything else when x is 0, okay? And that is what we're controlling, is the number that we're plugging in or inputting into this equation. We don't control the output, we just calculate what the output is. Let's do it with 1. So if x is 1, that's going to be y equals 4 times 1 plus 2. Well, 4 times 1 is 4, and 4 plus 2 is 6. So the output is going to be 6. Let's do it one more time where the x value is going to be equal to 2. So that would be y equals 4 times 2 plus 2. 4 times 2 is 8, and then 8 plus 2 is 10. So your output here would be 10. When x is 0, y is 2. When x is 1, y is 6. When x is 2, y is 10. I want you to go ahead and pause the video and try this same method with the other two problems that you see up here. And when you come back from pausing that video, I'm going to have the answers displayed on the screen. So I will give you a little countdown here and then pause my recording so that you can pause yours and do that without seeing the answers flash up there first. 5, 4, 3, 2, 1. Okay, so these are the answers you should have gotten, and I also showed my work so that if you didn't get something correct, you can kind of look and see what we did. But yeah, this is the gist. This is creating a table of values. What you're doing is you're listing what happens with a bunch of different types of inputs in terms of what's the output. That is the whole gist of this. And what you get with a table of values is you get a set of points, coordinate points, that give you an x and a y value. So each one of these pairs, 0, -5, 1, -3, 2, -1, this is a pair, this is a pair, and this is a pair, and they are all representative of points that are on this line of this equation. And when I'm talking about the line, I'm talking about what the graph looks like when you graph this equation. A graph is a visual representation of what an equation looks like. If you need some additional examples or explanation about making that table of values from a linear equation, this is a link that will take you to a pretty cool video that helps you out with that. Pull up this document electronically and you can just click right on that. It'll take you right to the video. It's a couple minutes long. It'll help you kind of go through it just a different way, like a different perspective. Okay, once you have that table of values done, we can plot those points and turn it into a line. All you do is plot each individual point and then connect the dots. That's as simple as it is. So if you notice, I have 3 coordinate planes here, and I am actually going to use the data from the tables that we just created to go ahead and fill these in. So my first one was blue, I think, so let me run back up to the blue one. I have a point at 0, 2. Okay, so let's write down what all the points are. 0, 2, 1, 6, and 2, 10. And 2, 10 like this. Those are my coordinate points. Those are my pairs that I created that go specifically with this equation. Anytime I plug in 0, I get 2. Anytime I plug in 1, I get 6. Anytime I plug in 2, I get 10. So let's plot these using that whole like longitude, latitude kind of example that we gave before about how to plot things on a coordinate plane. The first point is 0, 2. So on the x-axis, horizontally here, I'm not going anywhere. I'm staying at 0, okay? And then I follow the y, which is the up and down, and that's going to be up 2. So 0, 2 goes right here. The next point is 1, 6. So I'm going to go to the right 1, and then positive 6 up on the y-axis is up here. And then I'm going to go 2, 10. Okay, so there is kind of an issue here a little bit. And the only issue really is that this thing is off the graph. I'm going to move this out of the way so I can show you what I'm talking about. The axis that I have drawn here, it only goes up to 6. But we know, because this has a line marker on the end, really this goes on forever and ever and ever. Like that goes and it keeps going. So this would be 7, 8, 9, approximately 10. So it would be 2, and then I would be all the way up here at 10. Now that's off the graph. That's what we call that when it kind of like spills off of the coordinate grid that we have. But it's fine for the purposes of this example. That's what I'm going to show you. So that's the 3 points. And then once you really only need 2, but 3, 4, 5, the more points you put, the more accurate your drawing is going to be. You need something that has a straight edge on it so that you can connect the lines appropriately. So let me just grab something from my desk real quick here. Okay, I just happen to have this Dunkin' Donuts gift card nearby that one of my students gave me, so I'm going to put this right here. And if you see, I'm lining that straight edge up with where the dots are, and I'm just going to trace a line like this. Okay, so that was really ugly at the end. I'm going to do it one more time. Hold on, let me just get this a little closer. There we go, like this. I'm going to try and hold this still and draw this line. That was much better. Okay, so that is the line that goes with y equals, what was the line? It was 4x plus 2. And that is all there is to it, ladies and gentlemen. That is how you graph a line using a table of values. We're going to do this process again with the middle and the last one. I will go ahead and do the middle one with you just so we're all on the same page, and then we will go ahead and work on the other one. 0, negative 4. 1, I think it's negative 3. Yeah. 1, negative 3. And 2, negative 2. I'm getting these values right from this table. 0, negative 4. 1, negative 3, and 2, negative 2. They go together. They're pairs, okay? Pairs of solutions. You're going to take 0 and negative 4. That means I start at 0. I'm not going anywhere left or right on the x-axis, but I'm going to go down 4 to negative 4. My next point is 1, negative 3. 1 means I'm going to go to the right one. It's positive. And then negative 3 means I'm going to go down 3. And then 2, negative 2. That means I'm going to go positive 2 on the x-axis, and then negative 2 on the y-axis. So I have 3 points there. It's looking like a pretty garden variety, like straight line. Let me just line this straight edge up here. And we're going to try really hard to hold that in place. Okay, that looks really bad. Let's do it one more time. Sometimes you have to erase and start over. It's just the way it goes. Let's see if I could hold this better like this. I think so. Okay, that was pretty close. Okay, it's not exactly through the dots, but it's close enough for what we're doing. This is a line. The equation of this line is y equals x, what is it, x minus 4, I think? Yeah, x minus 4. And that equation is graphed. That is the line that goes with that linear equation. Okay, pause your video and do the last graph, the same method that we've been following, and then when you unpause your screen, the answer will be flashed up on there. So make sure that you pause it now. I'm going to give you a countdown, 3, 2, 1. Okay, there is the answer displayed on your screen. You should have gotten a line that looks approximately like this. We have the 3 points graphed, and then I labeled the line with the equation. That's a good practice and habit to get into also, because sometimes you will have multiple equations graphed on the same coordinate plane, and it can get hard to keep track of all that, so it's good to label them also. Okay, we have one more thing to talk about, which is a couple characteristics of the slope and what the slope means and how we can interpret the slope, what it does. If you want to take a short break, this would be a good point to do that. The rest of the video, we're not going to have any breaks. We're just going to go straight through. Okay, so let's wrap up this section talking about the slope of a line. We know how to graph them now. We know how to plot those points. And now we're going to kick it up a notch and talk about this other aspect of a straight line, which is called its slope. A slope can be a positive or a negative number. It's a number that we assign to the slope that tells us, does the line, and I'm going to just use my pencil as an example, does the line sit straight like this with no curve, with no slant to it? Is it turned like this where there's a slant this direction? Or is there a slant like this where it goes this direction? Could it be something a little more subtle like this? Absolutely. Could it be a little more subtle like this? Absolutely. Could it be vertical? Okay. There is such a thing as a vertical slope, but that's out of the realm of what we're talking about today, so we're going to keep it simple. What else was I going to say about the slope? Oh, okay. So we also we read a graph of a line from left to right, just like how we read sentences or read a book. It goes from left to right. So if the slope looks like this, and it's from left to right, it looks like it's climbing up the mountain or going uphill, that's a positive slope. Okay. You don't know what the value of that is. It might be a positive slope of 5. I mean, who knows? You don't know that just from looking at this, but you know that it is a positive slope because from left to right, it is increasing. It is going up the hill. If the slope was like this and it was going downhill from left to right, that's left to right, then it's a negative slope, okay? And that's the best way that I personally remember it, is the uphill, downhill type of thing. Because when you're going up a hill, your elevation is increasing, and when you're going down the hill, your elevation is coming down. It's negative. It's decreasing. That's how I remember it. So that's how you could visually describe what the slope looks like. But in reality, in algebra, we typically need to know what the number or the numerical value of the slope is. And that's what we're talking about in this section here. There is a formula that you use to solve this. This is the formula for slope. The slope is rise divided by run. Okay? That's quite a concept. We're going to break it down. But it's the rise divided by the run. You can also think of this using this term where this is actually a Greek letter. It's the Greek letter delta. Okay, so let's make a note there. All right, this is called delta, and it means the change. Okay, so the change in y divided by the change in x. So that makes sense because that would be the rise over the run. If you're looking at a graph, right? Like how much rise or up and down, right? That's the y-axis. Do you have compared to how much run you have, which is left to right? Okay. So let's make a separate note of this. We'll use a different color. Rise is up and down, y-axis, and the run is left and right, and it's the x-axis. Keep that in mind, okay? Let me just get rid of this circle. Okay, so the other thing you need to think about is, well, how do you figure out the change in y? What is the run? Well, you need to have 2 points on the line to compare where one is in comparison to the other. And what this means is that you take the y value of the second point minus the y value of the first point. There's actually some text missing here, so I'm going to try and fill it in. I think it's purple. So the bottom of this would be x2 minus x1. Okay, and I know this seems like a lot. I'm going to try and break it down for you with some examples now and solve some actual problems. But this is a visual representation of what we mean. So here's a line. It's graphed on here. You have these 2 points. Okay, this is 1 point. This is another point. We'll call this point 1, and we'll call this point 2. Okay? And the way that you calculate the slope is you take the difference in the y values of these 2 points and then divide them by the difference between the x values of these 2 points. So applying this formula right here, let's do this, right? This is going to be x2, y2, and I'm saying that because this is the second point that we're talking about. This is x1 and y1 because this is the first point we're talking about. If you can do this with every problem that you get with slope, you can take this and plug it right into the formula and just chug it and get the answer without really so much even thinking about what you're doing. If you can define this, if you know this is x2 and y2 and this is x1 and y1, you are solid gold and good to go, and you can do this. So let's plug these in. So y2 is 3. y1 is -1, so 3 minus 1. x2 is 4, minus x2 is -2, so 4 minus -2. Now that looks super weird, right? Like that is not something that you normally see. We're going to put slope equals, by the way. That's not something you normally see. You don't ever see minus minus, because we know minus minus really just means add. Okay, that means addition. So let's fix that while we're at this, right? This is going to be 3 plus 1 divided by 4 plus 2. That's easy to solve. 3 plus 1 is 4. 4 plus 2 is 6. We can sort of actually reduce this a little because it's a fraction, and we can make this 2 over 3. Let me erase that and fix it because that looks weird. 2 over 3. That is the slope. That's the slope of this line. That is the rise over the run. This means, let's tie it all together. This means that every time that you have a rise of 2, you have a run of 3. And let's show you what that means. If I go up 2 from here, I now need to go over 1, 2, 3. And do you see how this connects to another point on this line? If I were to go up 2 and over 1, 2, 3 again, I'm at that other point. And I could have done this also if I knew that this was a point on the line and it's 1, 2, right? I could have used these 2 points and done the slope, but they gave me these 2, okay? So you can use any 2 points on the line to calculate how the slope is, what it is numerically. On our next page, we have some practice problems for finding the slope given 2 points. What we're going to do here is I'm going to go through the first one with you and have you practice the other 3 and then give you the answers, okay? So what I'm going to do is I'm going to call this point 1 and point 2. So let's define what that means. That means this is x1 and this is y1. That means this is x2 and this is y2. My formula for my slope is y2 minus y1 over x2 minus x1. So let's just plug in those values. The values I have for that are -4 minus 7 and then -6 minus 4. Now we know we can't have this minus stuff on the bottom, so we need to fix that. Let's rewrite our problem. -4 minus 7, -6 plus 4. Now we need to just simplify this and figure out what this comes out to. So if I'm at -4 and I take away another 7, that means I'm going more negative. So this is going to be -11. And on the bottom, I have -6 plus 4. That means it's getting more positive, okay? Am I still going to have a negative number though? Yes, because I didn't get enough out of the negative by adding 4 to this. This is going to be -2. Well, we know that a negative divided by a negative is a positive, so this is actually going to cancel itself out, and that's going to just be 11 over 2, and that's the slope. 11 over 2 does not simplify, so you leave the slope as that fraction 11 over 2. Okay, so go ahead and attempt the other three problems using this slope formula. First, define what point is which, and then make sure that you've labeled this x1, y1, and x2, y2, and then plug them in and see if you get the same answers that I get. I'm going to go ahead and give you a countdown because that way you can pause the video. When you unpause, the answers will flash up on your screen, okay? 5, 4, 3, 2, 1. Okay, so here's your answers. And you may have been stuck on number 4 or not really sure what to do with what you got. You might have gotten your answer as something over 0 and left it, and it's okay because you're starting at this. You're a beginner. It's fine. You're totally fine. But there is a rule in math that says that you cannot divide by 0. And so you might have even thought that and said, I know I can't divide by 0, but I'm not sure what to do. And that's fine also. I'm going to explain it to you right now. So I'm going to use orange, and I'm going to work through this problem. This is point 1, point 2, x1, y1, x2, y2. And my slope is equal to y2 minus y1, and this minus this. So this is actually 8 plus 13 over 17 minus 17. 8 and 13 is 21, and 17 minus 17 is 0. And you might have put this and said, oh, I'm good, that's my answer. Wrong. And I'm going to tell you why, okay, and it's all right that you're wrong. The reason it's not correct is because you cannot divide anything by 0. If I pull out my calculator right now, let me flip the lamp on and I'll show you, right? If I did 21 divided by 0, I get an error message. And I get that because you cannot divide something into 0 pieces. If I gave you a pie, here's your full pie. Let's say that, this is your pie, right? It's 1 pie. And I said, cut this up into 0 pieces. What would you do with that? You can't do anything with that. You just can't do anything with that. It doesn't work. You can't divide something into 0 pieces. So this is actually a situation where you would have an undefined answer. The slope is undefined because the denominator is 0. Now you might have been saying, well, what about number 3? Because when I worked that out, I got a 0 in the numerator, and the answer you put there was 0. That is fine, because you can have no parts of something that has parts. If I cut up a pie into 4 pieces, right, and there are 4 pieces all together, and I give you none of them, you have 0 out of 4 pieces. That's totally legit. You can 100% do that. So that's fine. But when you have that 0 in the denominator, that's when you need to take pause and say, oh, crap, I can't do this because it's going to give me an undefined answer. Okay, so there's some more practice with finding slope on the Delta Math assignment that goes along with this. So try that out and let me know if you have any questions. We are going to move on to slope-intercept form of a line. I think this might be the last. Yeah, this is the last thing, is slope-intercept form of a line, and then we have some word problems, but it shouldn't be too bad. So, why do we call it slope-intercept form? Well, there are 2 pieces that the slope-intercept form tells us about the graph. It tells us the slope and the intercept. It's in the name, okay? And slope we just got finished talking about. But what does it mean when we're talking about the intercept? What does that mean? Okay, well, the intercept on a graph, first it depends on if you're talking about the x-axis or the y-axis. In this case, when we're talking about slope-intercept form, we are always talking about the y-axis and the y-intercept. If you think about like this as like a football term, an interception is when the team passes I pass it to someone on my team, the ball, I throw the ball to them, and then someone from the opposing team jumps in the way and intercepts that pass for me. So let's say I'm standing right here, this is me, and this is my teammate, right? This dude right here is the opposing player. He's on the other team. And I'm trying to throw the ball across to my teammate here, and this dude is in the way. He intercepts the ball from me, okay? That is the concept of a y-intercept, okay? It's where your graph, your line that you just graphed, crosses the y-axis. It is where it crosses this axis. You can also have an x-intercept. In fact, if you look at this graph, it would be right here. This is where the line crosses the x-axis horizontally. This is that intersection point right here. But when we're talking about slope-intercept form, we are talking about the slope of the line and the y-intercept. The equation of a line that is in slope-intercept form has a very specific terminology that we use, or formula. The model looks like this. It is y equals mx plus b. You might have heard this terminology before. What this means is that the value of y equals the slope times the x value plus the y-intercept. The value of m here, I do not know why they chose the letter m to describe the slope, but commit that to memory, okay? We'll say m stands for memorize. Memorize. This means slope. Memorize that. It's very important. The m, this number, it's going to be a number. The number in front of x tells you the slope. The b value is going to also be a number, right? Like they're just telling you that it's b. Okay, I don't know why they picked b to stand for y-intercept. Let's make this red. Why not? It's already in red, so let's do it. You have to remember or memorize b means y-intercept. It is going to be a number, but it does not have any variables in front of it, okay? That's what you have to know about y-intercept form. It's always going to kind of look very similar to this. In fact, if you flip back to those equations that we did earlier where we graphed them, I'm going back really far in the notes right now. Okay, let's go to the graphs. Okay, this is in slope-intercept form. Y equals mx plus b. The m value here is 4. That means the slope of this line is positive 4, and the y-intercept is 2. Well, that makes sense, right? Because look at the graph. It passes the y-axis at 2, exactly. Okay, so we should have gotten slope of 3 and a y-intercept of -8. The slope is a positive number, and the y-intercept includes this minus sign that's next to it. Okay, time for the last section of this, which is about the application of the slope. So we have to sort of apply this to real world situations so that it makes sense to us exactly what it is that we are doing. Let's start with number 1. A company starts off with 5 employees. Every day for the next 10 days, they hire 3 employees per day. If you were to graph this situation, what would be the slope and what would be the y-intercept? Okay, so this is kind of, there's like a lot to deal with here. But really, in order for you to calculate the slope, you're gonna need to have 2 points that are on the line. So on the first day, okay, we're gonna have a graph here that looks like this, and this is going to be the days, and this is going to be the number of employees. Okay. On the first day, we have 5 employees. We started with 5. We didn't start at 0. We didn't have no employees. We had 5 employees. Okay. And then we know after the first day, we have 3 more. So that's 3. And then the next day, the second day, we know we hired 3 more. So we're like this. And then the last, that third day, we have more, and so on and so on and so on. So we know that it's steadily rising. The y-intercept is pretty easy to figure out because it's what you had on 0 days when you started. The y-intercept, the b, is going to be 5. Okay. Now, how do we figure out the slope? You need 2 points. So we know that on the first, on 0 days, we had 5 employees. And on the second day, really when 1 day has elapsed, that's how you can look at this, you had 3 more. So you had 8 together altogether because you added 3 employees. Now you have 2 points, which means you have enough to calculate the slope. So when you're calculating that slope, remember, this is going to be x1, y1, and x2, y2, okay? And when we calculate this, we're going to do the change in y divided by the change in x, which is y2 minus y1 over x2 minus x1. Okay, so that's 3 over 1, which is 3. The slope for this is 3. M equals 3. And you have just solved it, okay? Now, I did this little graph on the side here because it can be really helpful to sort of put this situation to a rough depiction of a graph, and it helps to kind of solidify your thinking about what's happening with the number of employees here. Are they going up or are they going down, okay? Number 2, you work at a clothing store. At 2 p.m., the district manager shows up and wants to know how your sales have been for that day. The computer that you have that does all your sales and everything produces the following graph that predicts what the sales will be like for the rest of the day. I didn't mean to say graph here. I'm sorry. This should say equation. Equation. Sorry, you guys. That should say equation. So your computer produces the following equation that predicts what the sales will be like for the rest of the day. What can you say about the t-shirt sales based on this equation? So this represents sales at 2 p.m. and forward, because this was produced at 2 o'clock. So we've already been open for a couple hours. We've already sold some stuff. So if we were to turn this into a graph, right? This is 2 p.m. This is the starting point. An hour later, an hour later, an hour later, 6 p.m., 7 p.m. Let's say we close at 8 p.m., okay? We started at 2 o'clock when this is really 0, 1, 2, 3, 4, 5, 6 hours. At 0, we started with 43. Every hour that goes on from there, we have gone up by 3. So this is 46. I know this because the slope is 3. And up, and up, and up. Okay, 49, and so on and so on. So the question is, what can you say about the t-shirt sales based on this equation? Well, drawing this really rough picture of what the graph is going to look like tells me that not only did I start with 43, but for every hour that goes by after that 2 p.m. mark, I'm going to have 3 more shirts sold per hour. If it's 4 hours, that means I'm going to have 12 plus 43 shirts sold, period. That's what the graph tells me. It tells me that shirt sales are increasing, and it tells me that the rate is 3 shirts per hour. And that's it. You need to be able to read a question and interpret algebraically what is happening. You might be given a graph, you might be given just the slope, you might be given the whole equation like we had here. You got to be able to interpret. Okay, last but not least, we have a question that says, the park charges a $3 fee for admission. The activities inside the park are very cheap. They're only 20 cents each. I don't know what kind of park this is or where it is, but I want to go because that sounds really cheap. Which of the lines below represents how much you have to pay if you go to the park and pay for some activities? So here we have a graph. Nothing is labeled on this graph except for these 4 lines. There's 4 different lines here. You have to pick, is it line A, line B, line C, line D? What line looks like it fits this situation the best? So what I would implore you to do in a situation like this is sort of label these axes. Okay, what is your input and what is your output, right? So the output is the total dollars spent. How much do you have to pay if you go to the park and pay for some activities? So this is the number of activities that we did inside the park. If we did no activities whatsoever, what's our cost? Our cost is $3 because there is a $3 admission fee no matter what. Just for me stepping foot inside there, it costs me $3 if I do no activities. So already I know both of these are wrong because it doesn't start at 8. It definitely starts at 3. This is for sure. So line A is out. Line B is out because they start too high. What about line C and line D? Well, it looks like if I follow line C, the more activities that I do, the higher my line is getting here. This is an increasing or a positive slope. What about the other line, line D? Is that a positive or a negative slope? It looks like as I continue to increase the number of activities, my cost is going down. Does that line up with what this paragraph says about this scenario? Is it that the more activities I do, the park is giving me a refund for that? Absolutely not. The more things I do, the more money I'm going to spend. So therefore, as this increases, this also increases. As we go further and further to the right, the higher and higher the cost goes on the y-axis. So line C is our correct answer. Line D is not it because the slope is decreasing. And that, my friends, is it. That is everything that we need to talk about in terms of how to graph equations of lines, how to make a table of values, how to plot points, how to connect them into a line, and how to discuss things like slope and y-intercept. So with that being said, and with this being our last video together for the summer term of Adult Basic Education, it has been a true pleasure. This is Mr. Dansby signing off, and hopefully I will see you guys again in the future. If I don't, best of luck to you in everything that you do. Best wishes. Thank you. Bye-bye.